This is pi, but how did Archimedes calculate it? Here's a formula that is derived from Archimedes' method that approximates the value of pi. We can input any positive integer for n, and the result will give us an approximate value of pi. The higher the value we input for n, the closer we get to pi. So now, why does this equation work? Around 200 BC, Archimedes devised a method for calculating pi by method of exhaustion. First, we create a circle with a radius of 1/2. Now remember that the circumference of a circle is equal to 2 pi r. So with a radius of 1/2, the circumference is equal to pi. Next, inside the circle, we inscribe a polygon, and we increase the number of sides repeatedly. What we can see is that every time we increase the number of sides of the polygon, the more it resembles the shape of the circle. Specifically, the perimeter of the polygon approximates the circumference of the circle. So let's derive a formula to calculate the perimeter of the inscribed polygon with an arbitrary number of sides. We know that the radius is 1/2, and we'll call the center of the polygon point A with points B and C as two vertices. Next, with line BC and point A, we construct line AD such that it is perpendicular to line BC. And incidentally, point D bisects line BC. So triangle ABD is a right triangle with sides A, B, and C, and an angle called theta. Line DC also has length A. Now, in order to find the perimeter of an equilateral polygon, we must find the length of one of its sides. Using trigonometry, we know that sine of theta is equal to the opposite side over hypotenuse. Looking at our right triangle, we can see that the side opposite angle theta is A, and the hypotenuse is 1/2. So A over 1/2 simplifies to 2A. Next, looking at one of the sides of the polygon, we can see that it is actually equal to A plus A, which simplifies to 2A. Therefore, the length of the side of a polygon is equal to sine of theta. The perimeter of an equilateral polygon is defined by the number of sides times the length of a side. We will simplify by replacing the number of sides with n so that the perimeter is equal to n times side. But we know that side is equal to sine of theta. Therefore, the perimeter is equal to n times sine of theta. Finally, we must find what angle theta is equal to. If we connect all the vertices of the polygon to the center, we can see that each individual angle is equal to 360 degrees divided by the number of sides of the polygon. And theta is just equal to 1/2 of one of those angles. So theta is equal to 180 degrees over n. Therefore, the perimeter of the polygon is equal to n times sine of 180 degrees over n. So looking back at our circle with a circumference equal to pi, we can understand why increasing the value of n approximates the value of pi, because the perimeter of the inscribed polygon with more sides approximates the circumference of the circle. Diameter to equal 1 unit, then measuring the circumference will give us pi.